Good morning. Welcome back to day 2 of Streaming Media Connect 2025, our 15th Streaming Media Connect event. I'm Steve Nathans-Kelly, Editor-in-Chief of Streaming Media and Chair of Streaming Media Connect. And it's my pleasure to welcome you all back today for our first panel of the day, How to Meet the Challenges of New Codec Adoption and Deployment, brought to you by Radiant Media Player. So we'll get started in just a minute here, but first, just a couple of housekeeping notes. The first person to correctly identify the track and the artist of the music you were hearing just as we were coming in will win a $50 gift card from Amazon, but you must be present to win, and we'll announce that at the very end of the session. So stick around, and of course, stick around because we got a great discussion ahead of us. Chat in the chat, that's what it's for. But we'll take Q&A toward the end of the session, so please put questions for the panel in the Q&A box. And if you put them in the chat, and there's a lot going on in the chat, they scroll away, so it's easier to see them in the Q&A. We will be back right here on May 20th to 22nd for the next Stream Media Connect 2025. If you want to submit if you want to be a panelist, you want to submit a topic idea, send it to the call for speakers, which is that link will be in the chat. Thanks, Bill. And sessions from all 3 days of Stream Media Connect will be on the Stream Media YouTube channel. That link will also be in the chat, and some of those panels are up already. Everything from yesterday is already up. So without further ado, I'd like to welcome to the stage somebody I've been working with for 30 years, but actually feels like only 29. Jan, good to see you.
Hey, Steve, how are you?
Good. So yeah, let's get this thing started.
Okay, I'll take it off. Just as a bizarre side note, Steve actually edited the first article I ever wrote for a technical magazine back in, I want to say the 90s. So it's
1995.
yeah, back when longer was better. Anyway, we're here to talk about not me and Steve, but how to meet the challenges of new codec adoption and deployment. And since 2020, where we saw 3 codecs launched by MPEG and ITU, and yeah, I guess 2018 when we saw AV1 come out, everybody's been talking about when will people start to use these codecs. And what we've done in previous sessions and this session is try and gather people who are either in the decision-making process for adopting new technologies or have already done so. And we've got a really stellar group today, people who are using some of these codecs that we're going to talk about, whether it's HEVC, AV1, VVC, I think is still out there for most people. But companies who are in the grips of saying, when do we do this, or we've done this, and this is the result. So joining me today are Behnam, Kakavand from Evolution Gaming, and they are well, everybody's going to tell you what they're doing. That's kind of the first part of the discussion. We've also got Arnaud Leyder from Radiant Media, and he's in charge of making sure the player can play all the codecs that you adopt. We've got Boban Kasalovic from United Cloud, who has a service that distributes video to, or helps their customers distribute video to connected TVs and other endpoints. And I know he's done both AVC and HEVC. And then Hassene Tmar from Meta, who is one of the engineers in charge of both developing the AV1 codec, SVT AV1, and distributing it. So he's got some pretty interesting stories to tell about how it's doing in particularly the mobile space, the Android, how it's doing from a software playback perspective on Android. So the format is going to be, I'm going to introduce the speakers, and then they're going to spend about a minute talking about their companies, how they distribute, whether it's live or VOD, which codecs they've adapted, when, and then we'll get to the questions, and those will be round robin answered, and that'll cover things like which codecs have you adopted, what process did you go through in deciding whether to adopt it or not, what have the results been. So let me kick off to the speakers. Let me start with Boban. Go ahead and spend a minute telling us what United does and the codecs you've adopted so far.
Hello guys. Well, I'm coming from United Cloud, which is innovation and development center. We are developing products and services for telecommunication and media companies. We have around 300 professionals working in the 5 development centers in the region. our main product is end-to-end streaming solution, which covers everything from encoding stage through CDN and to end user, which we also includes our multi-screen application on it. Currently, we're supporting major telcos in 7 countries in Southeast Europe with almost 2,000 live TV channels and 200,000 VOD assets. And we are also proud that our system is very stable and maintaining a live streaming throughput in terabits almost every day. So, and yeah, on the encoding stage, we are until now we are develop AVC and HVC, as you already mentioned. Later on, we will speak about the future. Yeah.
Okay, Arnaud.
Yeah, hi guys. My name is Arnaud Leyder. I'm the CEO and founder of Radiant Media Player, a commercial HTML5 video everywhere player. So we are a player company and we mostly deal with viewing and devices, smartphones and TV. And we are trying to answer that question is how to improve the viewer experience in terms of playback quality and player features like closed captioning, live and DVR and all of that. So we do not stream ourselves. However, our customers do stream and they mostly use H.264 with H.265. This is what I can say as of beginning 2025. They do a bit of on demand. We have a lot of live streaming, especially for sports, soccer here in Europe, rugby and all of that. Yes, and for the coming months, we'll be having a closer look at how VVC is doing and also Dolby Vision, because we are having a lot of requests from people who want to improve the visual experience for the viewer.
Okay. Why don't you go, Hassene?
All right. Hello, everyone. My name is Hassene Tmar. I'm a technical program manager at Meta. I support the video infrastructure team, which is the core backend and to a certain extent front-end team that's responsible for ingesting, processing, and delivering a few billion videos a day that our users do. Meta is a company that builds apps to bring people together, and video is one of the most aspects of these apps and the most aspects of bringing people together as well. Today we work with 3 main codecs. VP9 is the codec that we use today for VOD, where every video is going to have a VP9 rendition. We use AVC now as basically for legacy devices and a few lanes for legacy. And we use AV1 for premium encodings. And so if you have a lot of fellowship, then you're probably going to get AV1. Yeah, and then we'll talk about the exciting stuff we're doing with AV1 there in a while.
Okay. Behnam, tell us where you are and what you're doing from a codec perspective.
Hi, thank you, Jen. Thanks for having me. Yeah, I'm Behnam Kakavand, video R&D lead engineer at Evolution. Evolution being the largest provider of live casino in the world, as the name implies, in the live, and we are doing live streaming 24/7, operating close to 2,000 channels globally. And currently we are doing the AVC and the video only and Opus and AAC on the audio side of the things. And our main user base are basically on mobile phones, but we are targeting all of the possible platforms. Basically, if users can't see a video on any platform, that would be good for our business, definitely. And for the next codecs, we are actually considering AV1, not HEVC, sadly, but AV1 is the thing that we are hoping to go live in 2025.
Okay, why don't we kick off with that analysis? Where are you with that? Tell us about how you're going about making this decision.
Well, yeah, of course. I mean, the first and foremost thing that to make a decision regarding a new codec is definitely the playback support and how many percentage of the users out there can actually see the video that you are going to invest so much in producing. And with that, I mean, it's everyone is seeing very great boost. Hardware encode decoders on the mobile devices specifically is coming out in newer generation and of course premium devices. But we've seen times and again, especially from Meta, during DMAX and Mile High Video as well, that it looks like that the software decoding is not too bad actually. So that's a very big positive thing. The next thing that we are considering is actually the encoder availability. I mean, it's not sufficient to have a great standard. You need to have great encoder as well, and not two encoders are. I mean, each and every implementations are different. I mean, these standards are usually define the decoding process. It's up to the encoder vendors to implement their own tools and everything to make it a usable encoder. To give you an example, for example, the AVC libx264 currently provides tools that in PSY or CRF, these tools are actually, you may not be able to find in other types of encoders, but I mean, of course, it depends on the encoder software or hardware, the encoders. But we evaluate all types of the encoders to see which one actually provides us with benefits that we are looking for. Bandwidth saving, of course, is the big talk of the day. Everybody's talking about that. But it's something that will come over time. At the beginning of it, we are not looking into bandwidth savings, but improving the current quality that we are providing to our users, and to be able to do that with reasonable costs, it's an important thing that we are testing for. And at the end of the day, the goal is to provide the best user experience at a reasonable cost for both for us and the users as well. Newer use cases such as 4K, UHD, and HDR, of course, on the table when we are talking about the new generation codecs as well. So I hope that answered your question.
Okay. Arnaud, tell us about the decision you go through when you look at implementing a new codec, and what is the last codec that you added to your player stack?
I would say, widespread compatibility is the first thing I would look at. We are in a multi-platform world where you can't just, push content to one specific channel. You have to push on social media, on mobile apps, on your website. And I would say that in my experience and what I'm getting from our customers is for people dealing with industrial quantity, having a prototyping strategy, an end-to-end strategy to test and validate your encoding from the server to the end device is, of paramount importance, because, for example, we found out with the customers that Instagram at the moment doesn't support AV1 in WebM format. It does work with H.265 MP4, but if you try to upload a WebM AV1 video to Instagram, it will come back with an error message saying incompatible file format. And they are using, WebM and AV1 to stream with MPEG dash to the mobile apps and website with our player, but they still need to go, to other channels and other platforms. And this is the world we live in today. We have to push on various platforms, various devices. So for people who are dealing with large quantity, it's very important to make sure that once you push a, encoding command, all the chain from the server to the CDN, to the player, to the viewer, because now we're talking about what the viewer is experiencing in terms of visual interface with HDR and other, new visual effects like 3D. So yes, having that strategy is important if you want, to not make mistake and run through a lot of cost of having to re-encode hundreds and hundreds of video because you miss one specific platform you wanted to support.
Okay. Boban, walk us through again the codecs you support. I guess it's AVC and HEVC. And how difficult was the decision to implement HEVC? And tell us about that decision. What did you consider?
Well, in our case, because most of our customers using first screen, B screen for the watch television, we, let's say, have easy decision. And it was we implemented last codec which we implemented was HEVC. It was almost 2 or 3 years ago. Decision was driven by bandwidth saving, or the top rank especially, which is the most watching on all our customers. HEVC brought serious cost saving, and it has become, let's say, de facto standard in our system. It has a wide, at that time, it has a wide support on consumer devices, making the switch from AVC relatively smooth. In our case, a crucial moment was that all first screen devices, which we take the biggest impact in viewership, supported HEVC in that time. But there is another side of that story. The more codec we support, the more expensive the system is. So like we starting with AVC, and you put in HEVC on top of that. Let's say we reach 40% fewer bits, but you're not reducing the bits on the edge and on the storage. So it's not just decreasing the cache cost on the distribution cost by 40%, and it's because you still have AVC, and now you have HEVC, and in future we have AV1 on top of it. We are also increasing for storage and network cost for a primary distribution. So there is one very good behavior of the viewership at telcos which we supported. Let's say just top 30 or even top 20 channels have viewership rate around 90%. Related to this, telco operators that we support implement HEVC just on those top, let's say 20 to 30 channels, and have really big reduction on average bit rate, which gave them a really good cost saving. So that's how we implement HEVC and make a decision.
What about the HDR side? Is that something you're passing through, or?
Until now, there are no huge requirements on HDR, but we will do something during this year related to HDR, of course.
Okay. Hassene, tell us about when did AV1 start to make its way into the meta delivery ecosystem, and what did that look like at the start, and where is it now?
Yeah, so I would say 2022 is our first kind of big launch on AV1. We started with a value proposition of adding quality to the Reels product, which at the time was a very famous product on our family of apps, and very soon after we deployed, we saw the iOS watch time on Reels go up to about 70% for AV1. So we found it to be very successful, even though we were using software decoders at the time on iOS. So then we found out that, even a little bit before that, that maybe one way to go. We have discussed, or my co-panelists have discussed the need for a good encoder, need for a good decoder support. We're one of the lucky ones where we can send a decoder in our apps and bundle it in, and so that helps quite a bit. We have invested heavily into an open source ecosystem, and now we have a vibrant community around it that helps support all of these aspects, and that adds a lot to it. But then we found the new dimension here, which is basically if we can use the encoder to actually speed up the decoder, because the encoder could do whatever it wants. And so we worked very closely with the SVT AV1 team to develop these fast decode recipes that helped us push further down the complexity of the software decode. And as such, we kept, ramping up and up the AV1 reach. Today, I'm happy to announce, and it's been announced by my colleague David Ronca last week, that we passed the bar of 50% watch time on VOD platforms in AV1, and which is a great success for the team and everyone that worked on this. And even on Reels for iOS now, that number is closer to 90% of the watch time. As we see hardware decoders ramping in, then we just basically shut down the software decode and take the hardware decode and go through that phase of swapping out things. But it's been a great success so far, and we moved out from a quality boosting feature, using AV1 as a quality boosting feature, to using AV1 as a bitrate reduction feature now that we're a bit happy with the quality level we're at. And so we hope to, help the folks that are with the limited bandwidth have a better user experience. And that's very important for our users as well.
Talk about some of the benchmarking that you do on the Android platforms to determine whether or not they can play software and how that impacts the decision-making process about which codec they actually watch.
Yeah, that's a good question. Android has definitely been the most challenging platform to deploy AV1 on. It's not because it can't, it's because of a bit of the fragmentation of the specs on Android phones. And that gives us a bit of a challenge. And so what we started doing was to go as simply as possible to do an offline analysis on the decoder on any ARM platform. We started with Mac Minis, we go down to the Raspberry Pi, Orange Pi, and then we just run a decode and we measure the cycles. How much cycles are we using? It's been published in multiple papers that measuring cycles gives you a close to linear correlation with energy, and so that was a good proxy for us. So after we did that, we found that things like the fast decode recipes are decreasing the amount of cycles that the decoder would use significantly down to further 25% down, which was super awesome. The libdavid decoder that we use, the open source David decoder that we use, is basically has done a great job in optimizing further all of the subroutines into Neon assembly, and that helped significantly. They use the latest and greatest kind of versions of Neons when available, so that helped. And so we took that and we started saying that, okay, so now we have a good starting point. How about we start running some battery tests? So we take a bunch of streams, we use some open source tools like VLC benchmarks, and then we basically run the video for hours and hours. And we found that an $80 Android phone could decode and run video for more than 16, 17 hours and so on. And it still has battery to go. We were happily surprised with that. And we thought, let's keep going, right? So, lately we partnered with the Itium team to build a little bit of a different benchmarking tool or building on top of VLC benchmark with some little changes to it and how things are done. And we called it VCAT that my colleague, again, David Ranka, talked about last week in Malhai video. And in this, we're hoping that this benchmarking tool would be kind of a bit of moving forward the standard of benchmarking on mobile devices, where you can ping hardware decoders, software decoders, any decoders really. And by running these tests and getting them running in an automated way, it helps not only folks that are working on the player like Arnaud or the phone manufacturers, the chipset manufacturers benchmark properly to a use case that's most basically representative of VOD nowadays and UGC content. And as such, we will be able to see things like energy usage, battery usage, and all of these aspects. So that's our little journey so far.
Okay. Arnaud, could you go into, if I'm a publisher, I choose a player. Once I choose the player's in charge of making sure the video plays on the platforms that I want it to play on. Talk to us about how challenging that is as a player developer to make a player compatible with all the platforms that are out there. And talk about how that works. I mean, are you developing your own AV1 player or your own HEVC player? Or are you using open source? I mean, how is that all working?
All right, so we are developing the player in-house here in France, Europe. We are a web everywhere player, so we actually are using HTML5 video not only to reach the web, but also mobile application and TV application for like LG or Samsung. So people are coming to us with that, specific want to be simplifying the work of developing a video application, and they often, request, our customers advice on how to best implement the codecs. Can you just, repeat the question? I lost track of the.
What is the certification process you go through to make sure that when you say we do AV1, you actually play on the majority of the platforms out there?
Oh yeah, so it's done with JavaScript. I don't want to go too much into the details, but we are using an API like the media capability APIs. It gives us, we are basically throwing at the device with JavaScript. That JavaScript API is directly plugged, to the device. So the device, can tell us, what it can do in terms of what codecs are supported. Is it hardware or software decoding? What frame rate is supported? How much, frame can I throw per second to that specific device without, negatively impacting the viewing experience? Resolution, of course. And there are, a few more opening for this API. Like I'm thinking about HDR, what kind of HDR metadata are supported, and what kind, like of color the display can render. And then, we can adapt based on that, the player can say to the server, hey, I have a device and can play, AV1 in HD, because yes, 4K is not available for that specific device because maybe it's another Android device at 30 frames per second. Give me that. This is, the best possible option. And then, we are working with our customers to implement a response from the server. Either they have, the file already available for on demand, or, you can, create a new feed for live. And then, they will produce the file that we need that best match, the playback capabilities of the device. So this is how we are doing, and we are seeing, a great result having a progressive approach with that. We are telling a customer, so you can have, on your server, like AV1 file in 4K, because AV1 shines in 4K. Like if you are doing 4K today, you have to do this in H.265 or AV1. You can't do it anymore in H.264 because those specific codecs and the newer ones that are coming, AV2 and all VVC, they will specifically address the concern of 4K, 8K, and maybe above 8K, we don't know. So that also is important to have that specific progressive approach. I'll start with AV1, like for premium content, like they are doing in Meta, like Hassene said. And then, I will have like maybe H.265, or maybe I'll just have H.264. You can go with H.265 and H.264, or AV1 and H.264. Dropping H.264 today is not possible because of all, the legacy device, the fragmentation of the market for TVs and mobiles. I mean, we're talking about mobiles, but TVs, smart TVs, like supporting older version of, LGs and Samsungs from 2015 is, very challenging because they don't support the same codecs. So we need to have, a constant a collection of information from the device and plug that to the server, so we can say that device, that customer that is paying a premium, I'm going to give him 4K, or this customer is watching ad supported, so maybe I just stick to HD. And based on that information that I want, that I've established, with my business model, and the information that the device is capable of giving us, we can make sure that the server will give to that device the best quality with minimum, playback interference at the minimum cost.
Okay, so what are you telling your publishers to do? I mean, because they have to supply all those streams, right? So,
yeah.
Is there
today, what I'm basically saying is H.264, you have a choice, you have to keep it because it's, legacy mandatory. H.265, this is for Apple devices. If you are specifically targeting Apple devices, because today we see projects that are not all channel specific, sometimes we see projects that only push to TV or to mobiles and only to certain types of mobile, maybe for just Apple customers, because there is a specific, story that the brand want to tell to Apple customers that is maybe different from an Android or LG story. So yes, that would be what I would recommend it. AV1, if you want to satisfy, the premium customers. H.265, if you want to, wow people on Apple devices, and yeah, H.264 for everybody else that want to watch the video. And again, make a clear analysis of who is your audience, what device you want to target, and then have a brainstorming session with your team to establish a strategy. I want to do AV1 and H.264. I don't need H.265 because there is a bit of overlapping between AV1 and H.265. And then, as I mentioned, pushes to the testing pipeline and making sure that the guys that are doing testing on the devices, if you have a testing team or even your developers can do that, they are getting what the quality and all the features, because I'm talking about decoding here, but I want to talk about GRM and server-side insertion and cross captioning, because today the people are doing all of that at the same time, and it's not just big companies that want to stream the UEFA final championships or major events. It's small and medium business are starting to do that now, GRM and adding closed caption, because for accessibility purposes, it's very important, and it's now a default standard that you have automated closed caption translation, for any major actors on the market.
Okay, all right, thank you for that. Boban, what's the motivation to look at AV1 for your group? What is HEVC not doing for you?
HEVC do almost everything, but well, of course, we are thinking forward, and like Hassene already explained, there is some kind of gaining momentum, especially with the hardware decoding rolling out in the newer devices such as smart TVs and mobile chips. And Hassene said there will be the software-based decoding also. In our case, because we are supporting telcos with our TV application on STBs, we know that nowadays more than 50% of those STBs are compliant with the AV1, and that is the good case for us. Depending on the implementation, it can offer maybe some great compression. We will see. Like you said in your previous conferences, it's not always a matter of codec, it's a matter of implementing a codec. Precisely because of the complexity of encoding, we are seriously considering to use hardware acceleration in this implementation. So far, we have worked exclusively on a software-based codec solution, but it makes sense to also consider hardware solution. Acceleration cards such as NetEase or AMD 35D can help us here, and also can significantly improve density on the encoding side, as well drastically reduce our power consumption on that. So this is, let's say, our point of view, and we will see during this year. I hope we will start this and have AV1 in our CDNs.
Ooh, interesting. Okay, and kind of the reverse question for you, Behnam. Why did you decide to jump over HEVC and go right to AV1?
Well, because the latest is the best, probably. But no, the thing is that what happened with the HEVC's licensing and legal stuff, and it basically came down to the point that our legal team did some investigation, and they decided that they don't want to take the risk. I mean, although it looks like that it might be clear that you will pay to a certain pool, and then it should be a fine, but they, due to the things that happened in the past with the licensing model of the HEVC and the new claims, patent claims that came to light, they just didn't want to deal with that. So we decided to go for the AV1 because it's supposed to be free and open source for everybody. And of course, HEVC provides, I mean, it's easier to move from AVC to HEVC because of so many similarities between the two encoders, two codecs, but that was an unfortunate, let's say, result of that non-technical aspect of the HEVC that we decided to go for the AV1.
Okay, I mean, a lot of your stuff, if not all of your stuff, is both live and low latency. So how are you dealing with that? I mean, looking at AV1, SVT AV1 is obviously very efficient, but are you looking at the software route, the hardware route, or what are you thinking is going to work for you?
Well, that's a great question. I mean, whenever you're evaluating any encoder, you have to evaluate it for your very specific use case. In our case, it's very, very narrow and specific. Our contents are basically live low latency, but we have the advantage of our content being very repetitive, the same thing. We have to, we are just basically setting the encoder and forget about it, depending on the content type. And that's what we are dealing here with. And when we are basically, could you repeat the question? Sorry.
You're dealing with low latency live. Are you looking at
Yes.
hardware encoding, software encoding?
Okay. Well, we tested everything, every possible encoder vendor, I mean, out there. There was an implementation. We tested it already in different versions. The latest thing that we tested was SVT AV1 version 3 that came out on Friday. We just started testing 2 hours after the release, basically. And one thing is that, I mean, AV1 and all codecs are great when you have actually time to encode. I mean, you can spend infinite amount of time, you will get best quality, best compression. That is not the case when you are dealing with low latency stuff. In our case, we actually don't see the big claimed bandwidth savings when it comes to encoding AV1 versus the H.264. The savings are marginal. What we are looking into is actually getting the better quality at comparable, obviously lower bandwidth would be better, but at comparable bit rates, which we haven't seen so far. But the SVT AV1 version 3 is showing very interesting signs, and we've seen the very big improvements in each and every release of the SVT AV1. And with the version 3, we are now seeing that even at preset 7 or 8, it can keep up with low latency live in real time, basically minimal delays. It can encode. And the quality is good, but it's still not that great. But what I'm saying is that you have to test for your own specific use case, and we are doing exactly the same thing. Our tests are very, very comprehensive. We always provide feedbacks to the encoder providers, and we are hoping to finally, this SVT version 3 basically is very promising. We hope to see something out of it in next, hopefully very soon.
What's been, I'm guessing you've tested the AV1 encoders from both AMD and NetEnt. What has been your experience with them vis-a-vis the quality that you need?
Well, not AMD. We were hoping to see a device from them, but we've never actually seen it. But NetEnt, we've been in contact with them for a long time, and a couple of years already. And we've tested that both directly from the devices that they provide us and from the other vendors of the platforms that they use the NetEnt cards. They are great, but you have to consider other factors as well when you're operating at the scale that Evolution is basically working, 2,000, close to 2,000 live channels. I mean, if you want to invest in a hardware encoder, the costs are going to be prohibitive. And you have to consider this, that we have all of our encoders are basically on-prem. And if you want to buy, I mean, devices for all of these encoders, I mean, it's a hassle. It's something that you have to consider. Will devices be available out there when you need it? Because we are expanding very aggressively everywhere. And if we have to hold on our basically new locations, new studios, just because of these this side of the supply part of the thing, that will be a game stopper for us. That's why we think that probably software encoders are a better bet for us.
Okay. Just when Meta encodes, they encode for millions of viewers. When you encode, I mean, you're encoding games. Are you looking at a limited set of viewers? Like, is it 10 or 20, or is it 1,000? I mean, and that really affects, I think, the bandwidth that you encode at. Mm-hmm. So are you looking at a small number of viewers or a large number of viewers when you do your encoding?
Well, we have different types of games. Some of our games, we are calling them game shows. They actually have thousands and thousands of people, tens of thousands of people are viewing at the same time. maybe not all of them are playing, but they are viewing it. These are very, very entertaining, basically, streams to watch. But some other types of games that you're right. I mean, maybe 4 or 5 people at the same time are using them. So the difference is huge, and we have to actually consider this. I mean, how much are we going to spend on a game that with a couple of people versus the other game with thousands and thousands of viewers? And we definitely adjust our bit rates and qualities and everything to address that. And we do consider different markets have different requirements. I mean, not all markets have the same available bandwidths. Not all markets have the same type of devices. So we consider all of these factors when we are basically setting up our encoders.
So it's set and forget, except you've got to come up with a lot of different recipes for.
Well, that setting part is a very long part. We are actually doing, I think I'm allowed to say this, and we are using things like in-house developed AI to find the best possible codec parameter sets for a specific table with given specific requirement of each market.
Okay.
So that setting part is pretty intensive, yeah.
Hassene, that raises an interesting question that I actually asked David Ronca. I mean, how much is Meta using AV1 for live at this point?
None, actually. So our live viewership is not as high as our VOD viewership, and such as Behnam and Boban talked about, live is a whole other beast to deal with. We did not find the kind of right incentive so far. We're still using AVC in there, and but we do use AV1 after the fact. So we have a a product called Was Live, and so after the live stream is done and everything is set up, then we retranscode that stream into a premium quality in VP9 or AV1, depending on some viewership conditions.
Okay, talk to us about the easy to decode switch you mentioned. What's the trade-off in terms of quality and playback CPU?
Right. So the SVT team did an analysis on tools and AV1 tools. If we use them within the stream, we look at how does the decoder behave to that, and the simple answer could be, turn off the tool if it's too complex, but we don't give up that easily. And so what we try to do is to go and kind of surgically use that tool when it's absolutely needed and gives the best possible trade-off. So the fast decode is the switch that we have in SVT AV1 that utilizes in a kind of intelligent way these tools, and of course there's a trade-off in quality. I think that the highest I've seen, which is at the highest end of the quality ladder, is about 3 to 4%. Maybe it can go up to 5% between the fast decode 0 and the fast decode 2. There's an intermediate level in there that in V3.0 we kind of reposition to be somewhere halfway in between. Now, but in the area where Meta is operating, we haven't seen a huge loss, maybe a couple of percent. And then as such, we just, as David mentioned, we just moved up in another preset, took a little bit of the quality gain, and with all of the speed ups that the SVT team are giving us, it wasn't really a big cost when it comes to energy. Now I want to touch on the energy piece a little bit here, because we talked about complexity and things like that. I think we're a bit of an open book when it comes to how we benchmark codecs, and we've published this in multiple forums. We're happy to talk about it. Please reach out if you want to. But so we basically use the convex hull algorithm to create the ladder. We're trying to use a little bit of a more sophisticated item internally to make sure to get that in the cheapest possible way, and we construct our ladder, and then we measure quality on that ladder. And so we don't measure quality on the whole thing. I don't need to measure quality when I'm encoding 50 megabits per second or whatever it is. I don't need to measure quality when I'm producing a VMAF of 0.5. I need to measure quality when it actually matters, right? And then in newer codecs, we're mostly interested in the area where I'm keeping the energy as the same as compared to the previous codec, or with a little overhead, not as much, assuming that we have a roadmap to close that gap, and then getting that bandwidth savings. So I'm not interested in a 30, 40, 50% if it's going to drive my energy usage 2, 3, 4, 5x, maybe 10x in some cases. I'm interested in how much can you give me at the same complexity. And we found that AV1 has been doing very good in that space. We can get from double digit and up in terms of bandwidth savings in that aspect. And so this is how we treat complexity. And I know I totally get, Behnam when he's saying, everyone has their own use case. This is the VOD use case, and that's how we do it. I do agree life gets and low latency gets a little more complicated than that. But I think it's, with better and better implementations, we'll be able to get there with AV1.
Well, I heard the quality side, the quality side maxed out at 5%. So on the decode side, how much more or how much less CPU is required for, in a short answer? Is it 5%, 20%?
Yeah, actually, we've seen it goes up depending on where you are on the quality ladder. In the mid range, we've seen it that we could save up to 25 to even 30% in decode cycles. In the highest quality, like the M0, M1 frame, yeah, we've seen a gap as much as 2x and a little bit more even because it's way too many complex features in there. At the very fast end, there is a good about 5% gap in there that you can still save, and maybe so more importantly for live applications as compared to VOD.
Okay. Arnaud, what are you seeing in terms of VVC demand at this point?
Not much, to be honest. And actually not generally recommending people to look into it right now because I think it's a bit too early. We're still in the process of maturing AV1 and getting everyone on board with H.265. So I would say VVC is a bit, early to adopt. But yes, you can run some experiments. And if you want to run an experiment on VVC, you can look into Shaka Player, an open source player that you find on GitHub. And it has a software decoding module for VVC, which actually allow you to port VVC even on devices that do not support natively VVC, legacy device and all of that. But my concern most with energy consumption, VVC being highly complex, decoding that on a software basis is likely to drain your battery low very rapidly. So yes, for experiment and starting to understand exactly what VVC can answer in terms of industry, streaming media industry questions. Yeah, that's my take on VVC.
Okay. Boban, any talk in your shop to jumping to VVC, or is AV1 definitely the next gen codec for you?
Yeah, for our side, it's definitely AV1, and unlike Hassene said, it's really important for us to implement it on live because this is our business case. And if we back just on the question about analysis, our analysis is fairly rigorous and it's data driven, but also driven by video quality. As you know, we developed our own VMAF tool using for live content. With this tool, we solved the problem with the frame alignment on the input and the output, which is crucial in live encoding and correctness of VMAF analysis. And this is a very powerful way to ensure quality and service during codec implementation. So for now, AV1, I can say that is on the roadmap. We will see in the future about VVC.
Okay. Behnam, how formal is your analysis to look at AV1? I mean, are you going to do a 40-page report, or are you just going to write some numbers on the back of an envelope and talk to your decision makers? What's that going to look like?
Well, actually, it's 50 page, not 40. It's pretty in depth. I mean, the amount of analysis we are doing, it's pretty in depth. We are testing on multiple type of streams, multiple type of most of the games that are attracting most viewers. We are using the same kind of contents to do testing. We test different, especially when it comes to new encoder and you don't have the grasp of the tools that it provides, the quality that it can provide each of those tools. As Hassene was saying, you can turn on and off those tools, and even when you're turning them on, there are different parameter sets that you can set for each and every one of those. So we go very, very in depth in all of those things, and we're testing for different resolutions, different bit rates, and different use cases. Yeah, definitely. And another thing that we have to consider is that what is the effect of each turning on and off of each of these tools. The other thing, other than the bandwidth and the quality that we are testing, is for the latency that it will cause. I mean, what is the frame latency? We measure each frame latency, and it shouldn't go over certain amount. You know, it's live because, you know, people are there is a certain degree of interaction between the users and what's happening in front of the camera live. It's not as low latency as the discussion that we are having right now, but it's pretty close. So we have to consider all of these things. And on top of that, then comes, of course, the bandwidth usage and quality. The one interesting fact that I should say here is that what we're seeing in newer generation, new implementations or new versions is that they do great in majority of the frames, for example, but we are very interested in seeing the lowest and the worst frames. And we see usually the degradation in the worst frames is huge. It's very visible, and it will have the effect on the quality of experience for our users. So yes, to answer your question, of course, we are doing very in-depth and very formal kind of testing, and we provide feedback not only to our own team, but the vendors and the codec providers.
Okay. Hassene, we have a question from the audience. What do we know about AV2? I guess we've been hearing about it for years, and I don't want you to tell any secrets, but what can you tell us about AV2?
Well, for now, it's called the next, AOM video technology, and it's not called AV2 formally yet. Let's say the teams are actively working on it, and then we will, we'll see what happens this year. That's as much as I can say publicly, unfortunately.
Okay, so this year. So everybody heard Hassene say this year, but
maybe
I'm just kidding. Arnaud, one of the things that's happened over the last few years has been the collapse in price of bandwidth costs. How has that influenced your customers' decision to implement new codecs? It's gotten a lot cheaper even to distribute AVC.
Mm-hmm. Yes, well, that's correct. So this was a relief for many of our customers. We can see that the money that used to be for bandwidth is now being reinvested in new video activities like, multi-angles videos or personal or branding, business branding, because today if you go with a video message out to this world, you need to have, a story to tell, a specific branding to it, and this has caused video quality of content, to be much better from our customers. Even small business or universities are able to stream better, a quality with managed costs, which is also one of the core idea with our player is to keep costs as low as possible. And this HTML5 everywhere strategy is also helping with the managing cost and that specific reduction in bandwidth cost is, yes, an opportunity to invest in new creativity and try to think of different ways to promote brands content to this world. And quality today is mandatory, because you have user generated content. I mean, you've seen some of those TikTok and Instagram video. People with iPhone shoot 4K video in cinematic mode, and you are having the impression that Hollywood is in the phone. And it's great to see people doing that, but it's also tell a message to businesses, and people in the streaming industry: be careful. People are getting serious about video, and you need to be on top of your game. And that relief in terms of money because of the bandwidth cost can allow brand to actually push that creative side of video with that money they are getting from the savings.
Okay, let me ask this one to Behnam. What's been the lowest latency you're achieving with the AV1 live encoding? What are you seeing with SVT AV1 and any of the hardware alternatives you're testing?
Mm-hmm. Well, the latest version of SVT AV1, from the very fast and brief look at I have, I mean, it was capable of doing around 20-30 milliseconds per frame. But it is obviously hardware. I mean, it depends on what machine that you are running it, and that definitely has a big impact on it. But the last time that we tested the hardware encoders was a long time ago, and we haven't tested the latest versions of for example, Netin's VPUs. But at that time, if I'm not mistaken, I don't have the number quite handy, but it was around 150 or 200 milliseconds per each frame. In general, in our case, the lower the latency, I mean, is better, of course, but anything above 150 milliseconds per frame would be a deal breaker for us. But I know for a fact that the latest versions of the Netin, for example, are capable of doing much faster than that. The thing that we tested more than a year ago.
Okay, let me, this is going to be our last question. Let me address it to Hassene, because I think you have the broadest distribution pattern. But what are you seeing in terms of codec types in different regions and different product categories? Or you're just painting with the broad brush of AV1, sounds like. But what are you seeing geographically, and what are you seeing across your product categories?
Right. Well, I mean, definitely it's phone or device compatibility based, right? So for AV1, we're seeing a lot of success in areas such as North America, even in Europe, in the UK. We're seeing a lot of success, simply put, because people would have the latest phones, would usually have hardware decoders on those phones. We track their user experience, and people are watching more videos or engaging in more videos, and that's all good. Now, surprisingly, also we've seen some great gains as we go into the low-end devices and the Android devices, and we're expanding AV1 in there. We're also seeing some better engagement in areas like India, where people do not have really good bandwidth, and they could use better video quality. And so at the same bandwidth that they are used to deal with, they are getting better quality, or sometimes it makes a difference between no video and video at all, to be honest. And then we use some techniques such as a mixed codec manifest, for example, where we can allow the ABR algorithm to switch between VP9 and AV1 depending on the phone capability and what it actually requires during that time. If a phone has only a VP9 hardware decoder and a software AV1 decoder, and its battery is doing well, and it's on Wi-Fi and things like that, the device is gonna say, "Okay, I'm good. Give me AV1. I can consume it, right?" But if it's constrained and it's going into higher resolutions and maybe on different kind of network, then it might just decide that, hey, maybe VP9 is good enough right now. So think about it: when you're driving and you put a YouTube video to listen to music, you don't really care about the quality as much, and so do our users. So they actually think that way as well. So sometimes they don't care as much about quality, and that's what it is.
Arnaud, anything from you on the geographical distribution of codec usage? And this will probably be it, because waiting for Steve to come up and give us the hook.
Yeah, well, to take the example of Hassene back in India, we have people with low bandwidth and device that can decode H.264, but you can't really, expect more than this. So you have large file, H.264 file that you need to deliver on a low bandwidth environment. So it's very challenging, and yes, the infrastructure are developing in countries like India or in Southeast Asia or in Latin America. It is helping, 5G and all of that. So yes, again, as I said before, it's know your audience, and the world today is more complex than it used to be, and the codecs fragmentation is not helping. It's where is my viewer, what bandwidth he's having, what device is he having. So yes, know your audience and make sure that you can do the best, technically speaking, and hope that the viewer will see what you want them to see. But we all know that in the streaming media industry, even with Starlinks and 6G and whatever innovation will be coming, satellites and Wi-Fi with light and all of that, the technology we have, streaming will always be fluctuant in nature, and this is why it's a constant learning process, and it's why we need to constantly know what's happening on the device, what's the viewer is doing, and collecting data is what we do on the player side. And we have new norms coming, like CMCD and CMSD, and they all are working towards the same movement. And I can see this on the player side, but I'm sure the people in this room, like United Cloud can this in the crowd. It's making sure that we have all the information along the streaming chain, and collecting that information to one central point that can make a decision, an informed decision. What do I need to give to the viewer so that the viewer is happy with the content?
Know your viewer. Great advice. Listen, I want to thank everybody on the panel. I know it's some of you had to wake up early, some of you had to stay late. I know it's an effort, and I appreciate you making it to help teach our audience the lessons that you've learned. So Steve, let me hand it over to you for the close.
Yeah, this was great. Thanks so much, Jan. Thanks everyone on the panel, and of course thanks to Radiant Media Player. This was a great discussion, and we went over. I think we could have gone another hour, and I think the audience would have stayed with us. This is great conversation. Before we go, I just want to do our Name That Tune Amazon gift card giveaway. The track you were hearing as we came in was The Frightened City by The Shadows, and Luke Wu was the first to get it right. So congratulations, Luke, and look for an email in the next week or so telling you how to claim your prize. We will be back here at 1 p.m. Eastern Time, 10 a.m. Pacific for LLMs on Air, generative AI use cases for news, sports, and entertainment. So we hope to see you all then. Thanks again.
Thanks, guys.
Thank you.
Bye.
Thank you. Bye-bye.
Bye-bye.